Welcome to part 6 of 8 of our City and Guilds CAD exam preparation. We're going to look at drawing techniques in this session. We're going to overview common drawing techniques. We're going to look at engineering drawings and some of the techniques that are used to create those. And we're also going to identify the use of concept drawings. I've recorded this about 20 times. Oh, and got that wrong every single time. Let's carry on anyway. The types of drawing techniques that we're going to look at to start with are listed on the screen. So we're going to look at what each of these are just in a basic form, and we're going to have a look at why they're useful. So we're going to look at isometric drawings, we're going to look at oblique drawings, we're going to look at planimetric or planometric drawings, we're going to look at perspective drawings, and then we're going to look at orthographic drawings. Do you know what any of these are? Well, you're about to find out if you don't. The graphic on the screen at the moment will show you lots of different graphical projection techniques: orthographic, oblique, first angle, third angle, cavalier, cabinet, curvilinear. Have you heard of any of these before? I'd not heard of all of them, but we're going to look at some of these as we go through the rest of these slides. So let's start first of all, not really a drawing technique, but I wanted to put it in here just as a precursor, just to identify that, the most common drawing technique is freehand sketching. There doesn't have to be any rules with freehand sketching, and basically you're just trying to create a representation of an object however it looks to you. Now, you may not be a great artist. I'm certainly not a great artist, and anyone who's seen any of my drawings will clarify that I'm definitely not a great artist. However, in engineering, freehand sketches are really important because they enable you to really quickly, easily portray an idea, and you've always got that the saying that a picture says 1,000 words. Have you ever tried to explain a shape to someone without giving it an actual name and without being able to draw it down? Probably not, because drawing makes things a lot easier. Isometric drawings are three-dimensional drawings. They show three sides, all in dimensional proportion. Now, that may be a bit of a mouthful, but basically what we're saying here is that if you draw something at 10 mil, then it is actually represented as 10 mil on the page. Not all of our drawing techniques are use that type of proportion, so we'll identify those as we go through. Now, all of these different drawing techniques will have different drawing angles, and you should be able to see how the shape changes a little bit. Now, isometric drawings are really easy to draw as long as you're drawing straight lines. As soon as you try to add curves or circles onto an isometric, you start having to draw ellipses. It then becomes very difficult, and it can become easy to make mistakes. We don't want to make mistakes when we're drawing or when we're sketching. We want it to be correct. We want to be able to do it quick. We want to be able to do it easy. So isometric drawings are really good for nice square objects. We'll have a look at a couple now. Before we do, I just want to go back and reaffirm what I said about dimensional proportion. So this cube is supposed to be a 10 mil by 10 mil by 10 mil cube. When we draw this on the piece of paper, all of those 10 mil sides and lines end up being exactly the same as each other. We don't have to scale anything. When we come to look at oblique drawing next, you'll see that there is some scaling that takes place. The other vitally important thing to remember here is the 30-degree angle. So here is a picture of an engineered drawing in isometric. You can see here, so we always start with a corner at the front. I'm just going to make that a little bit bigger. There we go. We start with a corner at the front. We project off 30 degrees each way, and we build our part up from that very first vertical line. Okay, so this isn't a task, that's an error on my slide. However, I mentioned that drawing circles was a pain in the backside because you have to transfer a circle into an ellipse. And look at this on here. Trying to draw this freehand is really difficult to get it just right. Yes, there are techniques that you can use to get it better. Yes, you can use a tool that's got an ellipse tool which got lots of little ellipses that you can just draw around, but we don't want that. These are drawing techniques. We want our drawing techniques to be nice and easy. This makes it a pain in the backside. And again, just imagine trying to draw something with lots of curvature and geometry, such as a water bottle. That would be a pain in the backside to draw that in isometric. So isometrics can be good, but they're not good if you don't have straight edges. As soon as you go curved, you're asking for all sorts of trouble. Here's some nice little pictures of isometrics. I thought I would go with something topical, and as we're currently in lockdown, a couple of weeks ago, obviously toilet roll was a main topic of conversation, so I've got a little toilet roll in there. This has been drawn in isometric, and if I was to take the center plane down here, it would probably come to about here. I could then project up 30 degrees and you can start seeing where my ellipse has been drawn. Same with this can here. And then over here with this box, again, this is much easier to draw because it's all straight lines. Once you've put your baseline in and you've projected vertical and you've projected 30 degrees and 30 degrees, it becomes very, very easy to draw. So our next technique is oblique. Now, oblique has a couple of different variants, and the first one that we're going to look at is oblique cabinet. So oblique cabinet is quite widely used in engineering. Now this is a step up from, or some people can consider it a step up from isometric, because with oblique, you draw your first part of your drawing, you take the most complex face and you draw that flat on the screen to make it easy for yourself. Then once you've got that, you then project backwards wherever you need to at 45 degrees. Now, with oblique cabinet, and only oblique cabinet, the scale is drawn, the depth scale is drawn half size. So let's have a look at what that means. So this is an oblique cabinet cube. It's the same one that was on the previous page. This is a 10 by 10 by 10 cube still. So we draw 10 mil, 10 mil, 10 mil, 10 mil. But then when we do our depth, although it looks like it's 10 mil, that is actually drawn at 5 millimeters. So our depth perception is half of the actual measurement. Okay, so depth perception is half. Now the other main oblique projection type is Cavalier. Now with Cavalier, we don't have the depth perception. So this is the only difference. So on here we can see on this drawing, the width of the cube is 24, the height of the cube is 24, which creates this nice square here. But then, oh, see, I told you my drawing was rubbish. But then we also draw this at 24 millimeters, and you can see that because of the perspective and because your eye expects the distance to decrease as it goes further away from you, it actually looks like this 24 mil line here has been drawn much larger. But I can assure you, if you measure those lines, they should fit. I'm going to admit now it doesn't look like it, so I'm just going to find something to measure it. Let's use this pencil. I'm going to use the old pencil measurement. And yeah, that's pretty good actually. It is pretty good. So have a look, grab something to measure it with and just try it. So that is supposed to be a cube, and it doesn't look like a cube. It looks like a rectangular shape. So oblique then is really good for drawing something with a complex shape, because you can, in 3D, because you can take the most complex part of the shape and draw it flat and then project all your lines 45 degrees off it. The problem is that Oblique Cavalier will make things look too long because the scale is drawn 1:1, and Oblique Cabinet will make things look probably shorter than they are. So here we go. Here's a side by side of Cavalier and Cabinet. This is the exact same part. You can see the Cavalier has been drawn at full depth, which makes it really easy because whatever you measure, you draw. The problem is it doesn't look very realistic. Oblique Cabinet, you have to remember to half the depth. So if I want this to be 20, I draw it at 10. That looks more like a cube than this one. Now you're still going to get some issues if you're going to start putting in complex bits and pieces up here, and it isn't actually our brain is tricked into seeing this as a three-dimensional object, but actually it should be a little bit more complex than this, because yes, we're giving ourselves a bit of perspective with depth by having the distance on Oblique Cabinet. However, all these other lines, the further away they go, these should also change in size. Okay, so we're going to now come on to planimetric drawings. So planimetric drawings, again, they're angled drawings, but this time we're angling a little bit more. So again, we've got a couple of different variants of this. So the first variant we've got this same center line that we had in isometric, and this time we're not using 30-degree angles, we're using 45 degrees. What does that do as a benefit? Well, actually, if you look down here, it enables us to show the plan area of something a little bit more. So this is great for drawing rooms, and probably some other things I can't think of right now. But this is great because it can give us a plan view, a realistic view of what a room or an area would look like. So the other variant we've got is just a slight twist on this. So we've got 90 degrees in here. We've still got 90 degrees in the second variant, but one of our angles is at 60 and one of them is at 30. And again, it can be either way round, it doesn't matter. And again, that just gives us a little bit more perspective. We can see more of the plan of the base of whatever it is that we're drawing. So again, used quite a lot for drawing room layouts, etc. in a three-dimensional object, three-dimensional fashion. Next up is perspective drawing. So perspective is what gives a three-dimensional feeling to a flat image such as a drawing or a painting. I'm reading off my slide now. It's a system of representing the way that objects appear to get smaller and closer together the further away they are from the viewer. So something in the distance will look smaller, something up close will look bigger. And that's what perspective drawing aims to bring to your three-dimensional images. So we're now getting a more realistic image. The problem is with this that you can't utilize it to make measurements, and it's not always the quickest and easiest way to draw something. So there are a number of different point perspectives that we can draw at. The first one is one-point perspective. So with one-point perspective, we start with a horizontal line, which is what we do on most of these perspectives. We pick a vanishing point. We then draw our first shape. So we'll draw the main shape here, the transversal lines. You then take the edges of those transversal lines, just change the shape, and we're going to go back to the point of perspective that we have. And that will help us form where the additional lines on our drawings are going to go. Okay, so that's one-point perspective. It has one vanishing point. Two-point perspective, again, there's a horizontal line going across here. We've got one vanishing point. We've got 2 vanishing points. Again, not again, this time as we do with isometric, we're going to start with an edge, a corner of a part, and then from that corner we can then start projecting those lines back to the vanishing point, and they will create the edges of our part. There we go, one there and one there. See, I told you I wasn't an artist. Okay, but this can create quite realistic drawings, more realistic than oblique, more realistic than isometric, but probably a little bit more difficult to do. And definitely you can't take dimensions off this, you wouldn't be able to measure it. Our 2-point perspective has a horizontal line, 2 vanishing points. We start with our transversal line, then we project back to the vanishing points on both sides, and that enables us to create the perspective of going towards those vanishing points. So we looked at 1-point perspective, 2-point perspective. You can actually go for 3-point perspective, 4-point perspective, 5-point perspective, and over here this is a 6-point perspective drawing, which basically creates a circular drawing for you. Really cool, quite difficult to do. The 3-point perspective drawings are pretty good because not only are you taking your 2-point perspective, your 2 vanishing points we saw in the previous slide, but we're also adding a height as well, which is what we would see in normal everyday life. So actually a 3-point perspective drawing is probably the most realistic. And if you look at it, to me, this looks like a cube that I'd find on if I'm wearing a VR headset with the perspective angles going towards those vanishing points. So just a very quick overview then of perspective drawing. So a perspective drawing can have up to 6 points of focus. Typically a 2 or 3-point perspective is utilized to create a real view effect. And what I mean by a real view effect is looking at actually drawing something which would be very similar to how you would view the object in everyday life. So they're the most realistic types of drawings for perspective. They're very easy to interpret, and usually you don't need to know or understand any of the techniques to draw these to be able to understand what they should be and what they should look like. So perspective drawings can be very good, not always necessary. You can't take dimensions off them. They can be a little bit more complex to draw because there's just lots of different things going on. However, they do look very realistic. So we're going to move on now to orthographic projection drawing. So we saw previously that actually orthographic, there are a lot of different drawing terms that could come under orthographic and drawing techniques. However, we're specifically looking at orthographic projection. So orthographic projection is a series of 2D drawings of a 3-dimensional object. So more often than not, a 2D drawing will be represented by up to 3 different views. And we can see over here we've got a front view, a right view, a right side view, and a top view. And each of those would be drawn flat on the paper. Now, these are used extensively in engineering drawing because you can show all of the detail on a part within 3, usually within 3 orthographic projections. Sometimes you want a couple of supplementary ones in there just to help visualize something, but for most things you can actually get away with 3 orthographic projections to show every piece of detail in a part. So the way that we draw those orthographic projections and how we position them will vary because there are 2 different types of orthographic projection. The first is first angle projection and the second one is third angle projection. Now on the next slide I've created a little video where I'm going to explain this in more detail. I'm sure you won't get it first time. There are loads of clips on YouTube if you want to go find out what first and third angle projection are. But have a look at the video that's coming up next, and hopefully that will clarify things a little bit more for you. To give you a quick demonstration of first and third angle projection, I've created a three-dimensional object in my CAD software. And if we look at the very front of this object, you can see that I've color coded it and wrote front on it. If I rotate it to the right, my right hand view is all the same color. If I rotate it to the top, you can see we've got pink. I've not written on the back, the bottom, or the left side, or the back. So what I've now done is move these into an orthographic projection drawing. So here's the three-dimensional object, an isometric view. You can clearly see we've started with the front face, which is the most detailed face on our part. That's in the middle. In third angle projection, the right hand drawing to the front face is the right hand part of the model itself, of the three-dimensional image. We draw the top on the top, the bottom is on the bottom, and the left is on the left. That appears to be quite logical to a lot of people, and indeed if this were a cube and I wanted to make this, if I connected all of these edges together, I'm just going to get rid of these pop-ups. If I connected all these edges together, I could cut that shape out and fold it all up and it would be like a cube. However, let's just reopen these back up. So that's third angle projection, where things, the right hand side is the right hand side of the drawing, the top is on the top of the drawing. If we look at a first angle version, you will see that it is a complete opposite. So this time our front view is still in the middle, but this time I've drawn the right hand side on the left hand of my part, and I've drawn the top on the bottom of my part. So first angle projection is used extensively, and some people say that this is a more difficult way of viewing objects. Some people say that third angle is more difficult. So why do we have two? Well, there isn't really an argument for that. We have two because people have done this in two different ways. Which is the best way? Neither. They're both as good as each other. As long as you know which one you're drawing or which one you're reading, it doesn't matter. What do you think would happen if you took a first angle projection drawing and you confused it and thought it was in third angle projection? What could happen, do you think? And alternatively, what could happen if we have a third angle projection drawing, but you believe it to be in first angle? Well, the worst that could happen is that the part wouldn't be right when you try to make it. You wouldn't be able to imagine it in the right way. Or potentially you could make the part back to front. And indeed I've had this in industry, and I've seen this a number of times, where people have made a part and it's in its mirror image to what it should look like. Sometimes that doesn't matter, sometimes it does, but it's just a key thing to note in engineering. One of the first things you should do when you pick up that drawing is have a look to see if it's first angle projection or to see if it's third angle projection. And if you are lucky enough to get a three-dimensional image with your drawing, just double check it, because again, not everybody does this, not everybody checks it. And I've picked up drawings when I've worked on in a manufacturing environment that's the drawing is stated it's in the third angle projection, and when you look at it, it's actually been drawn in first angle projection. Okay, so just a very quick overview then. We've looked at these 5 different drawing techniques We've got isometric, oblique and planimetric, all three-dimensional objects, all have some benefits and limitations, all can be not look particularly realistic, they can look boxy, things can look out of perspective. However, you can take measurements off them, and that sometimes is a very useful thing to be able to do. So remember, isometric is 30 degrees, three-dimensional object, everything's scaled 1:1, so you could draw things to the right dimensions, and later you could go back and measure them just as a double check. Oblique, you start with the complex face at the front and then you draw 45-degree angles off that. Oblique cabinet and oblique cavalier, two different varieties. Oblique cavalier, you draw the depth scale at 1:1, but it looks elongated. Oblique cabinet, you draw the depth scale at half, but then you must remember that if you then go back into measure. Planimetric gives us a bit more of a view of the base plan of something, so really useful for drawing out room layouts or factory layout or something like that. None of those look particularly realistic, but they all have their uses. They can all be a pain if you're trying to draw circles or you have complex geometry. The same can be said of perspective. So again, if you've got complex geometry and you're trying to draw something in perspective, it can be a bit of a pain. However, perspective drawings does take into the account the natural way that our eyes will see things. So the further something goes away from you, the smaller it becomes and the closer together it becomes to other objects. So perspective drawings look more realistic. So if you're trying to create a visualization of something, so you want to give it lots of color, lots of texture, you want to show somebody this is what this object's going to look like, then potentially a perspective view would be better than the other three above. Orthographic, now just be careful with this, is orthographic projection, because there are lots of different types of orthographic drawing. Orthographic projections are two-dimensional drawings of a three-dimensional shape. Normally you'd want 3 views to represent a shape, and from those 3 views you can get lots of information, you can represent lots of information. There's no scaling involved, or it's scaled at 1:1, so everything you can draw is all going to be the same size. You don't have to worry about that or making any conversions. Orthographics are used quite extensively in engineering, much more so than any of the others, and we're going to come on to some engineering drawings next, and I'll show you why that's true and why they're used so often. Okay, so now we've come on to more of a technical engineering drawing, and these engineering drawings are standardized drawings, and depending on where you are in the world, you'll often work to different standards. In the UK, we work to BS 8888, which is a British standard number 8888. It will often contain an orthographic or a number of orthographic projections of the three-dimensional object. You'll combine the image with bits of text, which should be kept to a minimum, and with dimensions. You should show hidden detail. There are a couple of other different view types that you can use, such as a sectional view that we can see just down here. So I can tell this is a sectional view because of this hatching that we've got going through the part. Orthographics are used because, as I say, you can just show so much detail and so much information. The problem with orthographics are that it can take a bit of time to be able to look at an object and really understand how those orthographics combine together to create the three-dimensional object. Nowadays with CAD, what you would normally find as well is some form of three-dimensional view on the object, on the drawing itself as well, just to help bridge that gap so you can see what the part should look like before going in to look at all of the exact detail. So that's it. A single part technical drawing will have just one part on the page. The drawing will supply all of the information required to manufacture that part. If it doesn't, the person who has drawn it, the designer, hasn't done a very good job. Okay, so the part drawing, a single part drawing, should contain all the information that is required to make that part. So on a multi-part drawing, you can basically have a whole assembly of something self-contained. So on here we've got 1, 2, 3, 4 parts, and then we've got the assembly to show you how to put all of those bits together. So multi-part drawings then are good for a range of similar parts where the dimensions are arranged in a table. So on here, if any of the dimensions are reused, so let's say there's a 20mm here, I could identify that dimension as A, and on this one I could dimension again 20mm A, and on this one A, and then in a little table I could have A equals 20mm. Okay, so it can share information, and it's basically because it's self-contained. It can make it easier. The offset of that is that you'll need a bigger drawing to work from. Personally, I prefer to work on it I prefer to have that as individual drawings, just to make it easy for myself, and I could focus on one thing after the other. However, if I wanted to share things such as dimensions, then I would combine them all into one drawing and put those dimensions into a little table. The third type of drawing that we're going to look at briefly is an assembly drawing. So an assembly drawing will show all of the parts on the drawing, and it will often show how all of those parts go together. You will also have this here, which is called a BOM. I'm just going to write that up here, BOM, which stands for a bill of materials, and this is a list with the quantities of all the different parts that are utilized to make the assembly. That can be really useful if you're assembling this. You can go through and check that you've got all the parts before you start. Okay, so the official line on this then is that an assembly drawing shows the correct relationship between the component parts of a product, and it may also include a tabulated parts list, which is our bill of materials up here. And can you see that these balloon numbers will be represented by the item number? Then you can take the part number, sometimes the part name, it may have a material, etc. So it makes it really easy to be able to understand what's in that assembly and how different things go together. The final type of drawing that we're going to talk about is a concept drawing, a prototype drawing. So a prototype or a concept drawing is a drawing of a part and the very early stages of a design. So you're just kind of thinking and rolling through with some ideas. You will often use a sketch. If you looked at one of my previous videos, you would have noted that I would have said that when you're designing something at the very early age, you wouldn't often be sat in front of CAD straight away. You would be creating some little drawings on a piece of paper, which is why it's important to know about all those different drawing techniques and how so you can adopt one or another to be able to create these designs. Now, as I said before, you don't need to be an artist to be able to create concept drawings, because you can put annotations on. So annotations are these little bits of extra writing. You can see here, look, tube for airflow. So it's just about conveying an idea. And if we look at this, what type of drawing is this? Is it been made out of any of those specific techniques? Probably not. There's probably a little bit of isometric in there and it's all twisted. Does that matter? No, it doesn't, because you're getting across the idea and the concept of your design. Now, you wouldn't spend a lot of time on these types of drawings because they may get changed many times. I've sat in design offices, in design meetings, where we used to have a big whiteboard and we would draw concept drawings on the whiteboard, and over a series of hours the part would just transform and change into all these different ways as everyone was throwing in ideas, and we'd end up coming up with an idea that we all thought might work. And it's at that point that that would then be given to a specific designer or a CAD jockey, whatever you want to call them, and it would be up to them to then go and create the CAD models to see if it was going to work and to see how all the parts would relate and to put the finer details in. But for a concept drawing, you don't require any of that. It's just about expressing some ideas, some thoughts at a very early stage of a design. So a couple of questions for you then, just to get you ready for this CAD test that you're going to do. Describe 5 features for each of the following pictorial projection methods. So 5 things about each of these pictorial methods. In an engineering scenario, explain the role of each of the following. So a single part drawing, a collective single part drawing, and assembly drawing. So what is the role of them? Why, where and when would we use each of these? Okay, so just a little short paragraph. And number 3, what is the purpose of a prototype drawing? Good luck, and remember, all of these things may come up in a test. Thank you. Oh, I'm glad that's over. That was a difficult one today. Oh, I'm still recording.